Hi students, welcome to my channel CSIT tutorials by KanyaKumari. In this video we are going to discuss what is a graph data structure and what are different traversals. Okay, so what is a graph? Graph is a non-linear data structure. So linear data structure means the elements are stored like this, the elements are stored like this, the elements are stored like this or like this. Okay, so graph means a non-linear data structure. So when we will use this graph data structure means, so whenever the nodes you want to store in the form of a network. So that means here it is one system, here it is another system, here it is another system, like this. Now the connection you want to give in between these systems, then this graph data structure is used. That's why here it is called as a non-linear data structure. Okay, and this is called as a connected graph. This is called as a connected graph. Okay, so now there are different types of graphs are there. Okay, so what are the different types of graphs generally used? This is connected graph because this is called as vertex in the graph, and this is called as an edge. So graph is represented with the G, which consisting of set of vertices and edges. So V means non-empty set of vertices. Non-empty set of vertices. Generally in three data structure we will call them as nodes, no? In the same manner here these are called as vertices. So what is E? E is nothing but non-empty set of edges. Non-empty set of edges. Now you can give the names for each vertex, like this is some A, B, C, D, E. Suppose edges like E1, E2, E3, E4, E5, E6, E7. See, then V equal to set of vertices, na? So V is nothing but what are the vertices present in the above graph? A, B, C, D, E. Now what are the edges present in the above graph? Like E1, E2, E3, E4, E5, E6, E7. So E1 is an edge between A and B. This may be A to B or B to A. Why? Because there are no directions present in the graph. So that graph is called as undirected graph. If there are directions are there like A, B, C, D. Suppose I am mentioning the directions like this. Then it is directed graph. Here it is called as undirected graph. So suppose E2 is in between B and C. That means B to C bidirectional. Whenever here we are not mentioning any edges, then that is bidirectional. Okay. So like that, directed graph, undirected graph. Similarly, weighted graphs are also there. So weighted graph. Weighted graph. Weighted graph means in between the vertices we are representing the edges now. So for edge we will represent the cost. Why should we represent? You may get doubt why we will. Cost is nothing but a number. Why should we write a number in between the vertices? Okay. So cost here it is nothing but that may be time delay, time taken, or that may be distance traveled from one vertex to another vertex. That means for example A, B, C, D. So this is my graph. For example, this is my graph. So now 10, 8, 16. What is the significance of this edge cost? What is this called as? This is edge cost. What is the significance of this? A to B. A to B, to travel from A city to B city. To travel from A city to B city or B city to A city, the time taken is 10 minutes or 10 hours, like that. Okay. Similarly, the time taken here, this wait is nothing but I am taking in terms of time delay. So A to C or C to A, the time taken to travel from A city to C city, 16 hours or 16 minutes or 16 seconds. Similarly, B to D, to travel from B city to D city, 8 hours or minutes or seconds that will take. Okay, so that is the significance of mentioning the cost. So now this here I told you in terms of time, that may be the distance also. That means the distance between A city to B city 10 units. The distance from A city to C city is 16 units. The distance from B city to D city 8 kilometers. So that may be distance also. So depending on our application, so for what purpose we are representing the graph, is it in terms of distances or time delays or time? So based on that, here the value signifies. A to B the distance is 8 kilometers, A to C the distance is 7 kilometers, B to C something like that. So that's why, so here weights are mentioned, then that is called as weighted graph. If weights are not mentioned, then that graph is called as unweighted graph. Okay, students, till now we discussed different types of graphs like connected graph, then weighted graph, weights are mentioned now, weighted graph, unweighted graph, directed graph, then undirected graph. The combination of graphs may also present. That means weights and also directions may mention. Weight and that may be undirected graph. Unweighted with directed, unweighted with undirected, unweighted with undirected. Like that, generally everything should be a connected graph. So like that, the combinations are also may present. For example, here A, B, C, D. A to B 8, B to D 2, D to C 8, C to A 6. So here directed weighted graph. What is this? So directed weighted graph this. Okay. If you are not mentioning directions, then that is called as undirected weighted graph. Undirected weighted graph. Like that, depending on our application, we will represent the graph. So generally, what is a graph? Finally, you can say that graph is network of systems, network of cities. Suppose our state is there. In the state, different cities are there. A state Andhra Pradesh, different cities are there. So one city to another city, see here the connections between the cities. In Google Maps, it will give the connections from this city to this city, from this city to this city, then this city to this city. The connections. So that is nothing but simply what? Graph. That is the applications, one of the applications of graphs. Whenever you want to represent a network, then graph data structure is used. Now coming to the concept here, graph traversals. Graph traversals. Traversal is nothing but visiting the vertices. Traversal is nothing but visiting. Graph traversal is nothing but visiting the vertices present in the graph. Visiting the vertices present in the graph. If you consider a tree data structure, especially binary tree, we are having tree traversals like in-order tree traversal, pre-order tree traversal, post-order tree traversal. So, binary tree traversals, visiting the nodes present in a tree. So if you have not seen this video, you please see the video. What are different types of traversals present in a binary tree. Similarly, here also different types of traversals are there for a graph. So how many types are there? Two types of traversals are there. Depth first search and breadth first search. Depth first search and breadth first search. DFS. Depth first search. Then breadth first search. Remember, the data structure used in depth first search is a stack. The data structure used for breadth first search is queue. If you have not seen my stack data structure video, please see the video. What are the operations performed on stack? If you have not seen queue data structure also, you please see the queue data structure and operations performed. Okay. Now coming to one by one. Depth first search. Depth first search. So what is depth first search? So here, suppose vertices are there like V1. You can give any number. That may be city name also, no problem. V1, V2, V3, V4, and here V5 is there. For example, this is one graph G. G equal to V comma E. This is the graph G. Now I want to visit. See, generally one city to another city, if you want to travel, then there are number of possible ways are there from one city to another city. See, that means you want to visit, for example, you want to, suppose the graph is like this. You want to visit V4 vertex. This is the starting vertex. Then you can go like this, like V1 to V2, V2 to V4. You can visit, or V1 to V3, V3 to V4. Like that, number of possibilities are there. Okay, like that, depth first search is nothing but visiting the vertices. So now assume this is the starting vertices. So in what order the vertices are visited using this technique, depth first search technique. Okay, so in depth first search, start from any vertex, make that vertex as visited or mark that vertex as visited. Find the adjacent vertices for V1 vertex. That means, what is starting vertex? So starting vertex is V1. Starting vertex is V1. From V1 or for V1, adjacent vertices. Adjacent vertices for V1 are V2 and V3. What is meant by adjacent vertex? Edge present between the vertices. Na? V1 to V2, V1 to V3. Okay. Now, in between V2 and V3, visit any one of the adjacent vertex. So, in depth first search, I am repeating it again. Now see, start from any vertex. Start from any vertex. Assume starting vertex is V1. Mark that as visited. How can, suppose whenever I am marking 1 na, which means that vertex is visited. Okay. So this is the visited vertex. From that visited vertex, for that visited vertex, find adjacent vertices V2 and V3. Okay. So visit any one of the adjacent vertex. For example, from V1 you can go to V2 city or V3 city. Now my wish is to travel to V2 city. So mark that as visited. So first we have visited V1, then we have visited V2. I am writing visiting order here. Next. For V2, find adjacent vertices. For V2, adjacent vertices are, that means from V2 what are the edges, to which vertex edges are present. For V2 vertex, adjacent vertices are V1, V5, V4. So V1 is already visited. So visit V5 or V4. You can visit V5 or V4. Okay. So now for example, I am visiting V4. I am visiting V4. Now, from V4, for V4, find adjacent vertices. V2, V3. But V2 is already visited. Now visit V3. So visit V3. Mark this as visited. V3 adjacent vertices are V1 and V4. But V1 and V4 are already visited. Then what shall I do? What shall I do for then? So I have to move back. That means before going to V3, so I visited which city? V4. So move back. V4. V4 adjacent vertices V2 and V3. Why I am using this backtracking? Why? Because you have not visited all the vertices. V5 you have not visited. So you have to visit V5. That's why I am using this backtracking, which is possible by using the stack data structure. Okay, you know already backtracking uses a stack data structure. So I have uploaded one video which consisting of applications of stacks, backtracking. So backtracking you can use here. Okay, then so V4 adjacent vertices are V2 and V3. Okay, so now V2 already visited, V3 already visited. Then what shall I do? Again move back to V2 vertex. V2 vertex adjacent vertices are V1, V5, V4. V1, V4 are visited, V5 is not visited, so visit V5. So from V3 you moved back and then we have visited V5. Okay, V5. So you have visited all the vertices present in the graph and visiting order is V1, V2, V4, V3 and then V5. Okay, so in this way you can visit the vertices using depth first search technique. So if you have not clear of DFS concept, again listen to the video from the beginning. So example 2. Take another example like V1, V2, V3, V4, V5, V6, V7. Starting vertex is V1. So V1 is visited. See, V1 is visited. Mark that vertex as visited. Okay. So V1 adjacent vertices are V2 and V3. Visit any one of the vertex. Now I am visiting V2. So V1 to V2. Okay. Now find adjacent vertices for V2. V1, V4, V5. But V1 is already visited. You can visit either V4 or V5. I am visiting V4. So V4. Now, V4 adjacent vertices are V2, which is already visited. Now, shall I stop the process? So, as V4 doesn't have any unvisited vertices, shall I stop the process? No. In the graph, we have to visit all the vertices present in the graph. Students, please remember. We have to visit all the vertices present in the graph. Why? Because this is a connected graph. Okay, so from V4, so V2 is adjacent vertices which is already visited now. So again move back, backtracking V4 to V2. V4 adjacent vertices V1, V5, V4. V1 and V4 are visited. So visit V5, visit V5. V5 adjacent vertices only one vertex V2 which is already visited. Shall I stop the process? No. Then from V5 move back. V2 adjacent vertices V4, V5, V1 all three are visited. So move back. Before going to visit V2, which vertex we have visited? V1. So again move back, backtracking which uses stack data structure. So V1 adjacent vertices are V2, V3. V2 is already visited. Now visit V3. So mark this as visited. So V3 adjacent vertices are V1, V6, V7. V1 is already visited. Then you can visit either V6 or V7. Now I am visiting V6. So V6. V6 adjacent vertices are V3. Only one vertex visited, which is visited. So what shall I do? Shall I stop? No. Why? Because unvisited vertices are there. So move back. So before V6, which vertex is visited? V3. That's why move back. V3 adjacent vertices are V1 and V7. V1 is already visited. So visit V7. Visit V7. Okay, V7 adjacent vertices are no adjacent vertices. Now here all the vertices are visited. Okay, like that all vertices should be visited in the graph. So this is depth first search technique. Visit any one of the adjacent vertex. Visit any one of the adjacent vertex. Hope you understand, students. This is depth first search. In the next video, we will discuss breadth first search. How to visit the vertices present in the graph using BFS technique. Okay. Hope you understand, students. If you like the video, please share with your friends and subscribe the channel. Thank you, students. Have a great day. Bye.